Chapter 8: Algorithms and Flowcharts. Computer is an electronic machine. To make it work, it has to be given instructions called program. Thus, we can say that a program is a set of instructions in a particular language given to a computer to solve a particular problem. The first step in generating a computer program is to understand the problem and put down the steps in sequence to get the result. How to write a program? We write a program on computer by following the given steps. 1. Write an algorithm. 2. Design a flowchart based on the algorithm. 3. Conversion of flowchart into program. Algorithm. An algorithm is a set of instructions given to a computer to solve any mathematical or logical problem. In short, it may be defined as a step-by-step procedure to solve any problem. It is always written in simple language and precise so that anybody can understand it better. Characteristics of an algorithm. 1. Input. It has a well-defined input. 2. Output. It has a well-defined output. 3. Finiteness. It has a fixed number of steps which are performed in time. 4. Well-ordered. All the instructions are given in right order. 5. Unambiguous. Each and every step has a clear and definite meaning without any ambiguity. 6. Effectiveness. It runs effectively in terms of memory usage, resources used, and the time. Designing an algorithm. 1. Define the problem in simple and concise terms. 2. Make a list of inputs that are needed to solve the problem. 3. Make a list of outputs that will be produced as a result. 4. Write the steps in detail that are needed to work on inputs to produce the outputs. 5. Keep refining the steps, starting from the high level, until they are effective in computation. 6. Take the necessary data values to check and verify the working of algorithm. Advantages of an algorithm. An algorithm plays an important role to solve a problem in an effective manner. Let's have some advantages in support of this statement. 1. They are easy to understand and execute. 2. They make the removal of any type of error easy while solving out any problem. 3. They give clear description of all the steps needed to solve a problem. 4. They are free from any language specification. 5. They make conversion of flowchart into program easy. Some real-life examples. Example 1. Algorithm to take a bath. Step 1. Take a towel from the almirah. Step 2. Get into the bathroom. Step 3. Take soap from the shelf. Step 4. Turn on the shower. Step 5. Rub your body with the soap. Step 6. Turn off the shower. Step 7. Clean your wet body using towel. Step 8. Finally, get out of the bathroom. Example 2. Algorithm to pack a school bag. Step 1. Open your bag. Step 2. Take out your daily school diary. Step 3. Look up the timetable. Step 4. Get the necessary books from bookshelf. Step 5. Keep the books in your bag. Step 6. Close your bag. Some mathematical examples. Example 1. Algorithm to add to numbers. Step 1. Start. Step 2. Take two numbers. Step 3. Add the two numbers. Step 4. Print the result of addition. Step 5. Stop. Example 2. Algorithm to find the largest number. Step 1. Start. Step 2. Take three numbers. Step 3. compare the first two numbers. Step 4, store the larger number. Step 5, compare the stored number with the third one. Step 6, store the larger number. Step 7, print this stored number. Step 8, stop. Flowchart. A flowchart is a graphical representation of an algorithm. It is used for solving a particular problem by using some symbols and flow lines. These flow lines show the control of flow of instructions in a flowchart by connecting the symbols. Basic symbols and flow lines. 1. Start or stop box. It is used to indicate start or end of the algorithm. 2. Input or output box. It is used to indicate the input or output of data. 3. Processing box. It is used to indicate the processing of data or some calculation. 4. Decision box. It is used to indicate some decision-making process on data. 5. Flow lines. These lines indicate the control of flow of instructions. 6. Connector. It is used to connect the various sections of a flowchart to maintain its linear flow. Advantages of a flowchart. 1. It is a better way of communicating the logic of a system. 2. It is easier to understand a flowchart as compared to a program. 3. With the help of flowchart, problem can be analyzed in more effective way. 4. Flowcharts provide a good program documentation, which is needed for various purposes. 5. Flowchart is independent of any programming language. Limitations of a flowchart. 1. When the program logic is quite complicated, flowchart becomes complex to understand. 2. Designing a flowchart requires more space than writing an algorithm. 3. If some modifications are required, the flowchart may require redrawing completely. 4. The reproduction of a flowchart becomes a big problem as the symbols cannot be typed. Some real-life examples. Example, flowchart to prepare a tea. Some mathematical examples. Area of a square. The area of a square is equal to the product of its length and breadth, i.e., side times side, as both are equal. Let A be the side of square. Then, its area is calculated as A times A. Now, let's draw a flowchart.